And lastly, for this section, we want to talk about the integration rules for exponential functions. So if the derivative of e to the x is e to the x, then that means that the integral of e to the x with respect to x would also be e to the x, give or take a constant c. And the integral of e to the u du is going to be e to the u plus c. So remember that in this form, that du is u prime dx, so we're going to be wanting to look for the u prime, and we may have to multiply by a constant in order to get it. So in this case, I have the integral of e to the 3x dx, so my u is going to be equal to 3x, which means u prime would be equal to 3. So I need a 3. I don't have one. I'm going to bring it inside, so I'd have 1/3 times the integral of the integral of e to the 3x times 3 dx. So that makes 1/3 times the integral of e to the u du, which we know evaluates to 1/3 times the integral of, don't even need the integral anymore, we've already taken it. 1/3 times e to the u plus c, and e to the u is e to the 3x. So that would be my answer. Now for this one, it may look like you've got an extra x stuck out there, but you're going to need it, because if we let u be equal to x squared plus 1, then u prime would be 2x. So you can see that I need a 2 here. I've already got the x, so I'm going to multiply by 1/2 on the outside. And I'm going to rewrite this as 1/2 times the integral of e to the x squared plus 1 times 2x dx, because that's 1/2 the integral of e to the u du, which is 1/2 e to the u plus c, which is 1/2 e to the x squared plus 1 plus c. Again, I don't integrate or find the derivative of the exponent. The exponent stays the same. Now this is a definite integral, and you can do these just as well. So here we'd have u equals negative x, so u prime would be -1. So I'm going to need a negative here. And I'll rewrite it as negative integral from 0 to 1 of e to the negative x times negative dx, because that's my du here. So that's the integral from x equals 0 to x equals 1. E to the u du, again, we've got bounds in terms of x, or you can convert them to u if you want to. This would be negative e to the u plus, or we don't need a plus c because it's a definite integral, and that's going to go from x equals 0 to x equals 1. So that's negative e to the negative x from 0 to 1, which is negative e to the negative 1 minus a negative e to the 0. So that's -1 over e plus 1. And you can leave it like that. Some people would write it as 1 minus 1 over e. Some people would find a common denominator. It doesn't really matter. Any of those are fine. You can also do any of these types of extra integration problems with this. If you want to find a particular solution, that's fine. And with the derivative also, I mean, you can always find the equation of a tangent line. You just have to find the derivative. So here I want to find a particular solution of the integral of e to the x dx satisfying f of 0 equals 4. So I know that capital F of x is going to be the integral of e to the x with respect to x, which is e to the x plus c. So I need to find c. I know that f of 0, which is e to the 0 plus c, is equal to 4. E to the 0, anything raised to the 0 is 1, so 1 plus c is 4. And if I subtract 1, I get that c is equal to 3. So that tells me that f of x would be e to the x plus 3. You can find the area of the region bounded by curves. You can do anything you can do with any other function and its integral.